So let me show you how to find the sources or the self-extraction installation for this. Maybe even, first thing you can do is Google Irit Solid Modeler. You do Guirit on Irit Solid Modeler, and maybe I should send it to your chat also. And I will send the links directly as well, but you want to write it down. Let me try to open the chat. Okay, so let me send it to your chat also. If you Google this, you're very quickly going to find this website, and you're going to follow on this website where I was. So this is the website over here. This is the kernel. This is the kernel. In fact, you can find even the sources somewhere down here, but if you really care, it's a C kernel. But we are going to use the GUI, which is kind of 15 lines around down the website. You will see Guirit, which is the GUI, the graphical user interface of Irit. So this is the first website you want to watch. And I'm just sending it to you as well. If I click on this, and this is the last website we want to visit, this is the GUI, the graphical user interface of Irit. You have here the self-extraction automatical installation on Windows on the Mac. And I have to say that the Mac version is not well supported. We have only one Mac here in our group, so we support it, but it's not well supported. This one is much well supported. And I'm going to show you today the Guirit on Windows. So all you have to do is download this self-extracting archive, execute it, and it will install Guirit for you. That's it. That's the entire story. So again, this is in this Guirit website. And once you run it, you should see something similar to what I see over here. Questions? Ken?
Yeah. You hear me? Windows protected my PC.
Windows protects what? You can ask in Hebrew if you prefer, by the way.
כשניסיתי במקביל להתקין את התוכנה, אז זה כאילו ה-Windows לא מזהה, כאילו הוא unrecognized app.
הוא הראה מה? לא הבנתי. אתה מיוט.
כן, זה פשוט עם הרבע. בגלל, היא לא מזהה את הבעלים של התוכנה.
אני לא יודע איזה ווינדו יש לך, ואם יש בעיה, תדבר איתי באופן פרטי, זה לא צריך שום בעיה, אנחנו מתקינים את זה כל הזמן לכל מיני מערכות. נכון שאנחנו עושים את זה בעיקר בטכניון, אבל אנשים עובדים עם זה בכל העולם. יש מאוד משתמשים של זה בעולם, אני מתפלא מה שאתה אומר, אבל דבר איתי אחר כך.
בסדר.
נעשה שיירינג למסך שלך בשעות קבלה, ונפתור את הבעיה. אוקיי, היה עוד מישהו שרצה לשאול משהו?
אני אומר שאפשר להגדיר את זה בווינדוס, שהוא יסכים או לא יסכים לקבל תוכנות שלא מווינדוס.
אוקיי, אז אני חושב אדוארדו דיבר עכשיו, נכון? אז הנה, אדוארדו יכול לעזור לך גם כן. בסדר, עוד שאלות למישהו?
כן, ההרצאה עכשיו היא תהיה זמינה אחרי שההקלטה תסתיים?
כן, האמת שאני מקליט את זה, אני לא יודעת אם אני רוצה לשים את זה במקום ציבורי או לא, אבל אני חושב שזה כן מקליט.
זה מקליט, כן.
יש סיבה שהיית רוצה את ההרצאה? בגלל מה שאני הולך להסביר עכשיו?
נכון.
אוקיי, בסדר, אז אני אעלה את ההרצאה, אני אשלח לכם, זה לא בעיה, או שאני אגיד לכם במפגש הבא איפה זה יהיה. זה לא בעיה. טוב, אני רוצה להתקדם, אבל בואו נדבר טיפה על גוירית בכל זאת. תראו, כשאתם מעלים את התוכנה, היא מאפשרת לכם לעשות כמה דברים. דבר ראשון, ברמת העל, אפשר לטעון גיאומטריה חדשה, ואני אעשה את זה אולי בהמשך, אני אראה לכם דוגמאות של דברים שאפשר לעשות עם זה. סצנות חדשות וכו'. יש לכם פה אפשרות לקבצים קודמים שעבדתם, זה לא הכרחי, שמירה של סצנה, שמירה של מספר סצנות, ככל מספר סצנות בסביבה הזו, בקאפ, שאני אפילו לא משתמש בזה, לא יודע בדיוק מה זה בעצמי. אתם רוצים סצנה חדשה לגמרי, אתם יכולים פה, לשמור מטריצות או להריץ סקריפטינג. הסקריפטינג, אני אדגים לכם אותו פה, אבל הוא מאוד מאוד פרלימינרי, אז אתם מוזמנים להשתמש עם זה, אם תרצו להיות בטה טסטרים של זה, אבל זה לא הכרחי. ויש פה אפשרות לשמור את המסך כתמונה, לשמור קונפיגורציה, זה חשוב. לשמור קונפיגורציה שומר לכם את כל מצב החלונות, אז אם מעדיפים את החלון דווקא ככה, ואני אשמור את זה כך, אז פעם הבאה שתיכנסו זה יישמר בדיוק כך. אם אתם מעדיפים את זה ככה, או אתם מעדיפים לקחת את זה ולשים את זה, נניח פה בצד, אז תשמרו את זה וזה יישמר לכם כך. וזה דווקא שימושי, זה אני עובד. עושה קונפיגוריישן, שומר את כל מצב החלונות גם כן, וזה גם מאוד מאוד שימושי. אוקיי, Windows. אז Windows שומר לכם, יש פה מצבים של חלונות, כמו שאמרתי, אתם יכולים לשמור מספר מצבים. אני עכשיו אעבור למצב סקריפטינג, אני יכול עכשיו לפתוח פה סקריפט, שאני אעשה את זה בהמשך, ולהריץ אותו בתוך כדי לראות, אז יש פה מצב חלונאות של נורמלי, שזה המצב הרגיל, ואתם יכולים לשמור פה מצב נוסף ולתת לזה שם, וזה יופיע לכם פה אם אתם רוצים את החלונות בדרך אחרת.
גרשון?
שאלות כל הזמן, כן, תפריעו. הייתה שאלה למישהו.
אני רציתי לדעת אם אתה יכול לעשות פול סקרין, שנוכל לראות יותר טוב.
אתה רואה? אפשר.
ונקודה עוד אחד, אם לא התכוונת להרצות באנגלית, אז אולי...
לא הבנתי, טטיאנה, מה?
התכוונת להרצות באנגלית או בעברית? כי עברת בעברית.
You're absolutely right. I have to switch to English.
Okay.
Thank you for reminding.
Thank you.
Okay, so I'm switching to English. I'm sorry about this. Okay, so basically, anybody else? Okay, so...
רציתי לשאול אם יש מדריך לתוכנית הזו? כתוב
יש
כאילו.
מה? Sorry?
כאילו מדריך לאיך להשתמש בתוכנית הזו.
That's a good question. In fact, I didn't mention it, but there is, when you install this, and maybe I would show you, everything I show you today is also, and that's a good question, is also on the directory when it's going to be installed. You're going to see a directory similar to what I'm going to show you now. Let's see if I can make it bigger a little bit. Okay, this is the bigger I can make. Anyway, let's go to details. There is a way to change the font here. I don't know if you see this, but there is several doc files under a docs directory. So you can read the doc files from there, and it will give you idea how to use it. Most of what I will show you today, even though you can also, if you really want, find ways to download the software and compile it and install it yourself if you really want to. That's not required because you are required only to install the compiled version, but if you're interested, you can do it. So definitely there the documentation. The documentation is installed pretty much as part of your installation. So having said that, we talked about the files and all the options under files. Talk about Windows. So Windows, you can switch the windows from one window to two separate windows. So if you want two views in this direction, you can look at, maybe I should show something so you will see the geometry, and I will return to this. But here, for example, I have a cube, I have another cube, and I can do two views, either way, like this, or if I want four views, all are possible. It's very easy. And let me talk about the mouse control because I'm starting to manipulate. If you look at the screen, you get a hierarchy on the right, you get the main screen here, and you get some information screen and scripting screens down there. And then you have all the icons on here and here. By the way, it's my experience that CAD system, geometrical CAD system, are one of the most complex system in the world. In fact, it's remind me of PowerPoint. How many of you know all the functionalities that are available in PowerPoint? Probably no one. I mean, these are very complex systems with many options. So this is also true here. So don't be alarmed by all the different options. You will find what you need and you will use what you need. So having this hierarchy here and the geometry there and the scripting tools there and the general information screen there, you have some icons also on the left. The icons are similar. So if I want two screens and I'm in object, I can get two screens like this or like that, or four screens from there as well. In fact, the most used icons are always shown up here. So these are the last four icons I used. So you can always get to the last few ones over there as well. There are many icons over here. I'm going to go them as we progress. For example, this allows you front view, back view, left view, right view, upper view, down view, and then some isometric view, general view. And we can do orthographic and you can do perspective. Okay, this is the camera, by the way. You can hide things if you go over here, right-click on the mouse, and then you see a menu. So right-click on the mouse, give you a menu, and right-click on this, and I want this camera, so you see it's highlighted in cyan. I do hide. Another way of doing that, and there is another object I want to hide. I want to hide this object. You see it's slide 2. I can do it right-click here, but I can also type H for hide. So I hide everything actually by mistake. I didn't mean to do that. So let's do S for show. And this shows this, and this shows this, and this shows this. In fact, I can show the grid also, and I can show everything by an S. So I can show by an S, and I can hide with an H, or I can right-click here and do hide, and then hide, and then hide, and then hide. Usually, it's up to you if you want to see that or not. I do like to see the axes. These are kind of helpful about the axes, and I'm going to hide this. Another way of hiding it, by the way, is double-click on the object. Double-click here, I hide the object. Another double-click, it shows. If I hide it, double-click here, I see an axis with red, green, and blue arrows. Red, green, and blue, like RGB, it's very easy to remember for X, Y, and Z. RGB, like X, Y, Z, same order. So it's very convenient. Let me show it again. So double-click on this, showed it. Everything I did with the right screen here, when I showed the pop-up, and you see that the pop-up is different. Here I get a pop-up which has many elements. Here I have pop-ups that less elements, and here I have a pop-up that even less. So the pop-up menus are context sensitive to the geometry that you are manipulating. If it's a camera, I have a select view or store view, which I don't have if I do an object. So every object, according to its type, had its own menu. Now I did right-click here. I can do the same thing, right-click here. So the object here, box, is here. A blue, it's highlighting the object, so I know I'm pointing it. Now the axes are highlighted. Note that they are highlighted also on the right. Right-click, and I can select here the hide. Okay, I cannot do show because it's hidden, but I can do the show from here, and then I can see it here. So double-click on the text, shows or hide. Double-click on the icon, do this grid around the object. Another double-click hides the grid. And this grid is exactly the same as transformation, 3D transform. This allows me to move the object. Maybe not. For some reason, I cannot select it. Let me check something. Okay, so something is not working right. I can do the transformation from here and apply, but it should have been selected from here also, and I don't know why. Let's do this. Let me start over just in case I did something that destroyed this. Okay, so let me go full screen. We want the box, and we want the transformation, and now it works. I don't know what I did last time. So you see, I highlight the elements of the grid. So the boxes are for translation. Okay. The rounded cylinders are for rotation in all three axes. And this, sorry, what I left is the spheres. The spheres are for scale. Now, there is a transform here that is open when you do that. And you can also do manual. First of all, I could do reset current matrix. And so I go back to the nominal situation I started and say I want to rotate exactly at 44 degrees. So I can write 44 around X, or if I want around Y or Z, and I can do apply, and now it rotates 44 degrees around X. Again, reset, I can do translate in, say, in Y, 1.1. So I do apply, and then it moves 1.1 in Y. Now,
Gershon,
translate, Ken.
all the units are pixels?
No, these are unit world coordinate. This is what I mentioned earlier, object space. This is the space of the object. So it can be millimeters, or it can be meters or kilometers, depending on what one unit is you care for. Okay, so let me reset it again. Notice when I rotate, it rotates around a weird axis. It's not really clear around which one it's rotating. Because for rotation, we have a center of rotation. Translation is clear. It's always translating around the object as much as needed, but scaling and rotation has some center. If I scale, it goes down to 0 at some weird location. It's not really clear. And the reason is that there is a center for rotation and center for scaling. So if I do control-click here, control-click, it tells me where is the center of transformation for scaling and rotation. It doesn't matter for translation. So I will do origin. So now the axis origin is going to be selected. You can type any number you want here to be the center of transformation. And so if I now do scaling, it goes back to the origin of the object. Okay? If I do rotation, it rotates around the axis. Okay? Because now the center of transformation is exactly this point here. The default is, by the way, now that the default is the center of the object, so kind of you move it around the object, and sometimes it makes sense as well. So make sure that you do control-click, left-click, if you want to do it the way you want to do it. Okay, so we talked about how to transform object. Let me hide objects here. You can always go, by the way, to transformation. If you don't like what you did, there is a reset here, reset object transformation. So you forgot about the transformation you did to the object. That's another possibility. By the way, if I point an object highlighted in cyan, and if I select it, it's shown in this color, kind of magenta color. Okay, so I'm going back to the windows. We saw these four. These are exactly the same as what you had here. Up, down, left, right, bottom, front, and some isometric view, orthographic perspective view. And you can go to next and previews. You can save a camera. You can go to full screen. In fact, it's in my other screen now, so you don't see anything. Doesn't matter much. You can select which screen to present it. I will show you later. And some OGL properties. I'm going to skip that for now. We'll return to that. Let's talk more about geometry. So far, we just talked about round stuff. And I'm going to skip this one, and I'm going to go to CSG. CSG stands for Constructive Solid Geometry. This is a way of creating geometries by creating primitives. You see the primitives here. And doing what we call Boolean operations. Boolean operations are exactly the same Boolean operation you remember from combinatorics or set theory or whatever, in which case we take all the object and we consider all the points that are inside the object. Obviously, there are infinitely many. And we consider objects that are points that are either in one object, one primitive, or the other, and that's called the union. In one object and the other object, and that's called intersection, or in one object and not in the other, and that's called subtraction. And you see a union, intersection, subtraction. And let's do it. Let's assume that I have a cylinder. This is my cylinder. Let me show you, first of all, how to change parameters in the cylinder. You see that when I click on one of these geometry constructors, like the box here, a box primitive showed up here, a sphere primitive showed up here, and cylinder. Right now, we allow only one constructor like this to show up in this hierarchy here, in this area. You can do something, you're done, and then you can go to the next. And if you switch to another one, you're going to lose the previous one. So the reason for that is beyond what we want to discuss now. But remember, this is a possibility that you have to take into account. So now the geometry has some parameters. And I was asked about the commentation. If you double click on the title of some object like this, you're going to get some short description of what this is about. Or you can wait with the mouse and a pop-up will show up with some information. Some are very simple, like this one. Some explanations are going to be longer, but again, you're going to get context-sensitive explanations here. Okay, so the base of the cylinder in this case is in 0, 0, -1. Let's change it to be 0, 0, 0. Okay. The height is 0, 0, 2. Let's change it to be 1. Now, there is a way to use these numbers as sliders. If I type Control right-click, and these mouse bindings are discussed in the manuals I mentioned earlier that are kind of part of the directories in the docs, or you can write them down. Control right-click, I change like a slider, the parameter. Okay, so let's return it to be exactly 1. And let's change the radius. All the yellow numeric value that you see here are always sliders that you can change number in. Now you see that this cylinder is a polygonal cylinder. In fact, you see that it has 16 faces. You see the number 16. If I want a finer cylinder, change the number here to be, say, 64. And it doesn't have to be multiplies of 2. It can be 60. Oops, 460, that will be too much. 60. You see, it still looks pretty smooth. In fact, let's do OK now. So I have a cylinder. I created a cylinder. Let's right-click on this. I get the menu, and let's look at rendering options on this object. There are many ways to view these objects. Polygonal drawing style. You see it here. I can change the color of the object. I can change it to green, and it's green. I can draw it solid, or I can draw it wire. You see, now you see all the wires that represent the polygons. I have one big polygon here with 60 edges, and then these are all squares, rectangles if you like, and another one on the bottom. And I can do only the wires if I double, no solid. Okay, and I can change the color of the wire. I want the wire to be blue. Okay, and I can change the thickness, like 3. Okay, so there are many, many options here. I'm not going to go over all of them now. You can explore them yourself. Some of them are not useful for all objects, but you can change the display by rendering options. You can change the default display if you click here, and you get the default display that you set. So if I now change the default display to be blue, or to make it cyan, to make it a little bit lighter, if I create new geometry, it will be created according to the default global geometry. So now the sphere is kind of bluish or cyan-like. Okay? So you have full control to set the default values when it all starts. And if you do save configuration that was here at the beginning.
Can I ask one more question, please?
Yes, just a second. If we do save configuration, it also save the default values that you set here. Question?
Yes. What's the primitive on the top of the cylinder? It's not actually wireframe doesn't show up on there. So.
Well, that's the arrow. If you're asking about this axis, this is the arrow of the axis.
No, not the arrow of the axis, but the top of the cylinder itself, the circle and the inside. It's not a polygonal.
This is the polygonal cylinder. I'm not sure I understand.
Yes, but the top is not the polygonal object.
It is a polygonal object. A polygon with 60 faces. In fact, it's a polygon with 60 faces.
Ah, I see. It's one polygon with 60. Okay, thank you.
Yeah, but it is usually converted to triangles, or sometimes. So if I show in
No, sure. I understand. I just didn't get it that it's one polygon. Yeah, sure. Thank you.
So we created a cylinder. We are here in the CSG. Let's create another one. Let's create, say, a sphere. I have a sphere. Again, I'm going to use the right-click, change the properties, and I just move it around, and I have the two intersect. Okay, so let's say look at these two objects, and let's do some operation. Let's do intersect. Union is going to be boring in the sense that we'll see nothing else because it will look exactly the same. The only way to see that the union worked is because you look at the wireframe, you see that something in the interior is missing. So let's do intersection and then subtraction. So we'll see intersection will just give me some weird shape over here. So let's do intersection. I click on intersection. Remember, in my hierarchy, I can always move around like this. I have now a box that is hidden. Here is the box that is hidden. I have this cylinder that I highlight now, and I have this sphere. So now I open this Boolean. I select the first object to be the cylinder. No, this is the green cylinder, sorry. And the second object, I'm going to select the sphere. Now that I see also the hidden object, the box, you can still select it. It's still selectable, but I select the sphere. And if I do OK, I see the result. And see that the result is shown in the default color I selected. Okay, remember that. Everything is going to be created like that. Let's hide this, double click, and let's do the subtraction. I'm going to select, again, they're all hidden now, by the way, because when we use parameters and the intersection, we use the cylinder and sphere by its parameters, by default, it hides the parameters. Same thing here. You see there is hide parameters. Hide parameters mean I'm going to hide as a result of this, the two parameters that I got, the cylinder and the sphere, because I want to see the result. Otherwise, they're going to be covering the result. So here is the subtraction. It's the cylinder minus the sphere. Okay, so I showed you primitives, and we have like a tori and a cone. Let me show you. We can change the parameters in all of them in the way you would expect. So here I'm changing the base. Here I'm changing the height. Here I'm changing the base radius, and here I'm changing the top radius. In fact, you can do even reverse cylinders. It also has to be positive. It cannot be negative, but aside from that, it's fine. You can also do them baseless. So now there is no base. Okay, by the way, the color here is magenta kind of because this is the default color we used here for back color. If I change the back color to be green, the back color is not going to be green as well. Okay, so let's do cancel here. Tori, just a second, I will give you a time. The Tori has, again, I can change the normal direction of the tori. I can change the major radius. I can make minor radius. And all I do right now is the right mouse click here on these slider numeric values. So play with that as well. Sheila.
Yeah, hi. If you make an action, let's say union or intersection, and then you want to, after you want to like edit the parameters.
Yeah,
so
it's a good question. Let's do this intersection, and remember, this is the intersection between the cylinder and the sphere. So there is a dependency here. I'm not sure if it's active or not right now, but you can do changes in the parameters. So let's say that I'm going to make the height a little bit higher, and then I have to hide it, and it updates the result automatically. Okay, so it does work. You have to activate it. I can show you later how to activate dependencies, and right now it's active here, so it actually works. So I have a bigger cylinder, and the intersection was computed on the fly. Okay, so the other option for Boolean operation, less important, like you can do negation of an object, inside, outside, cut, which I can demo cut just for the sake of seeing it. Let me hide this. Let's do cut of cylinder and the sphere. And so the cut just remove the zone in the boundary that is inside from the sphere from the cylinder. So in fact, you see into the cylinder. In fact, all this Z fighting is because of the axis, the grid. And so you see it now nicer. But you see inside because the cut just take the first object, just the boundary outside the second object. Okay. And so you can play with the other option. This got just give you the intersection curves. Now, primitives in our system in Guirit have many different forms. They can be polygonal, and so far we play with polygonal objects. You can do that if you want in the model that you're creating. We have also surfaces, models, trivariate. These are the volumetric elements when you talked about heterogeneity. These are trivariates, and V models are in fact heterogeneous model consisting of trivariates. Let's do surfaces. If I do a surface, I create a cylinder, you see that I get some more information like all these isoparametric lines because this is a surface. Okay, but I can still do booleans. Let's do a sphere here. Let's do kind of a general situation. Say this sphere, and let's do an intersection or subtraction of the new cylinder from the new sphere. And the result is this Boolean. And now surfaces are going to be converted to polygonal objects when you convert them to do Booleans. If you want to do Booleans over geometry that is free form, you have to do at least models, and this is what I'm going to do now. Let me delete all the stuff until now. So let's do again a cylinder. And you see the geometry looks the same, but the representation with the isolines here, the curve that you see over there are a little bit different. Again, let's move the sphere a bit. And then I'm going to do a subtraction here. Cylinder minus sphere, and this is the result. And this is in fact a free-form geometry, full free-form geometry. This is precise. You can do it either way. I have to say that the polygonal Booleans are a little bit more robust. And if you will try to do something which is not really penetrating, things will not work in either way. So even if you do polygonal objects, I do a box like this, 0, 0, 1, and now I use apply. When I do apply as opposed to OK, it creates the geometry. Here's the geometry, but stays. So if using apply, I can create many instances. I can go to here, do another apply, go to there, make another apply, return to here, and so on. So I can do many applies like that. But now what I want to do is I want to place this one at level 1. So let's do like 0.2. 0.2 level 1, and then make this 0.5, 0.5, 0.5. So I have essentially, it's hard to see this way, but I will show you later. I type a 5 here. This box just sit on top of the other box. They are not really penetrating. They are not transversing. And this is singular. In fact, the intersection here is something we call non-manifold. I'm not going to go into details here. I'm going to hide these boxes. In fact, we can delete them. We don't care for them. We don't care for this either. Let me show you these two in wireframe. In fact, I'm going to leave just these two so I can do rendering options here instead of on the object, and this does it for all the subtree. So if you do rendering option, I affect both boxes because I did it on this that affect both boxes. And so I'm going to do just wire and not object. And you see they are sitting one on top of the other. Okay? And this is singular. And this means that if I do, say, an intersection, the intersection is just a plane. It's not a closed object. This is not going to work very well. Let's do subtraction. I'm not even sure what would happen, and I strongly recommend you to avoid such cases. You see, it's not happy. Unexpected fat error. Ooh, it's so fatal it actually died. So you see that you don't want to do these kind of things. Okay, so you know what not to do here. Let's go full screen. We are back in CSG. Let's go to geometry. Okay, so there are many advanced options beyond the basic primitive and Boolean operation you can do, and I want to go to curves and surfaces and then return to geometry and objects. Curves allow you to do free-form shapes. So in fact, you can do under curve sketch, and I can, for example, sketch a shape. What I did right now is Control, left mouse button. Let's do apply. Control, left mouse button, and I create the shape. And if I change the end conditions to be something called periodic, it even closes that. So these are all residing on the plane of the grid, of the axis, if you like, z equals 0. So I have a curve here, and I can do many things with curves, freeform curves. For example, I can edit the curve. So I have an edit here, and I will go to multi-resolution curve. So I'm going to edit the second one, sketch 50, and I have two ways to edit it. Let's look at it closer. I can edit control points, and the control points are very large. Let me shrink them so you will see. Oh, it's not working from here. So let's say that's something for me to write because that's something to fix. But you see the control points. The points I will show you them later in a second. Just a second. As I said, this is a system that is developed all the time. There is a default point size here as well. Let's hope that this will work from here. Point size, let's do it 0.1. Here, I did it here and under tools, OpenGL, default OpenGL. So let's quit and let's try again. Let's see if it picked up it from there. And then let's do this. Okay, so now the points are much more small and make more sense. These are something we call control points. For those of you who know, these are the B-spline control points, but it doesn't really matter much. And control left mouse allow me to pull them and move around the shape of the curve. So you see here the older curve, and you see here the newer curve that I now manipulate. And so you can manipulate it in any way you want. If you want to reshape it, you can do it this way. Another way you can do it is disabling this. And in this case, you are in a multi-resolution mode, meaning I can simply pull the curve and move it around. Okay? And I have a percentage of support. So I'm going to go to the two extremes. If it's very small, the effect is going to be very local on the motion. Okay? If I do very large, up to 99 or 100%, it will affect most of the curve. Okay? So you can do either way with control points or not control points. There are other options. Again, if you double click on the header, it will give you help about what to do here. There are other options like rational. If you know what it is, you can do it. If you don't have to know. I can open the curve and then I can manipulate control points from the end. It's going to be an open curve. And so I can change it as well. Okay, so I can manipulate curves. There are other editors. There is another editor curve here that you can also select the curve and change control points manually. I'm going to do it very quickly. So I'm going to edit the curve I just changed. And I can actually go here, and this is a slider, yellow slider, so I can change number manually. You can see them here. Or I can type a value, so I would say minus 1.3, and it moved. I can change the z value, but it was in the plane, but now it's outside the plane. You see, it's actually, I made the curve free space because I moved it outside the plane. So I can create very complex shape this way if you really want to. And this is one way of creating curves. Another way of creating curves is by clicking points. These are called Bezier curves. You can just click points, and then you can again move them around. And these curves are also editable exactly the same way as I showed you earlier. And then the third way, in the B-spline curve, you can do very complex curve and then move the shapes. So experiment with what you want and find out the best way you want to do it and do it the best way you want. There are other ways to manipulate curves, and I'm not going to discuss here. By the way, is another way to interpolate points. So if I click points, this curve is going to interpolate the points I gave you. So if you want the curve to go through a certain point, you can do interpolation as well. Okay, so I have many curves now. Let's see what we can do with curves beyond curves. By the way, I also have circles in different ways. So if I want a circle, I can have a circle. I can change the parameters of the circles. Again, the same sliding. I have ellipses. I have the center of two major and minor axes. So this is an ellipse. I can change the sizes of the ellipse, and I can move it around. So you have arcs and so on, you can play with this way. So like once I have curves, and it doesn't matter how you create the curves, you can create surfaces from that. And this is what I'm going to show now. So it's like alternative to primitives. These are much nicer, more general, more free-form alternative to primitives. Extrude is the first way I'm going to show. Extrude takes a curve, and I'm going to choose the way I choose, by the way, elements. I click here, I can choose a constructor, or I can choose the geometry from the hierarchy. And I'm going to choose the circle, okay? So here I created an extrusion, meaning I took the circle and I extruded it up. Amount that is set here, I can change even the direction of the extrusion. And I can even change the size from here. So this is just the vector of direction, and you can even taper it. Okay, if you want to make it kind of conical or open like this, you can also do that. This is operation called extrusion. Take a curve and pull it up in some direction. And then you can do Boolean operation with that. So if I take a cylinder from the CSG, and I'm just going to do that to show you that it's actually working, I'm going to make a horizontal cylinder. So you want the base to be, you want the vector to be in the y direction. And you want the base to be, you see, it's very convenient to kind of try to bring it to the right place by sliding it like this. So they are already close in one direction, but not in the other. So now I'm going to bring it from here, and now I'm going to bring it from here, and now to intersect. Let's take it a little bit down, and make it bigger, and move it back. Not in this direction, we want it in this direction. So now we are sure that they are intersect. Now, the intersection must be closed. If I will try to do Booleans with something like this, the intersection doesn't make any sense. So partially outside, partially inside. This extrusion is in fact outside. It's open. There's not really any closed object I can talk about inside and outside. So the Boolean operation makes no sense. But if I move it like this, I can talk about intersection, because the intersection is just this, and I can talk about the zone that is inside kind of the cylinder and inside the cylinder that you see over here, the extrusion and this. So intersection now will make sense. And so let's do intersection. Oops, you see, I lost it. I did a mistake I just told you I shouldn't do, and I just did it. So let's do it like this again. You have to remember to say OK, or you're going to lose your geometry. OK, so we are more or less in the right place. Let's make this one smaller. Oops. OK, this is the right level, and this is the right place. Okay, so we have the cylinder that I want. So now I can do Boolean safely. So let's do subtraction. And I'm going to subtract. I just want to verify. I want to subtract the cylinder that I just created. You see there is a unique number here, 1, 2, 3, 5 from extrusion, and you only have one extrusion. So that's easy. So you want to subtract from cylinder the only extrusion that we have. Okay, and this is the result. The cylinder subtracted the extrusion from the cylinder, so you see the cylinder is kind of diagonal from there. So in fact, the surfaces that you create can continue, you can still use them in Booleans. Okay, so I talked about extrusion. We can do ruling. Ruling, let's do two circles quickly. or two curves. Let's sketch two curves. Here is one curve, apply, and let's do another curve here. Okay, so I have two curves. They are not even very nice, or something might self-intersect there, but it doesn't matter. So if I do ruling is another way of creating a surface by connecting the corresponding points of the two curves into a surface. So I am going to select the first curve. I'm going to select the second curve. And I get a surface out of it that connect corresponding points between the two. Okay, and I, for example, decided that I want this curve to be somewhere in space. So I move it up and note that the surface is lifting up with that. So talking about dependency, something I was asked before, if the parameter is changed, if I change essentially the curve by transforming it, the surface that depends on these curves is updated as well. So we talked about extrusion, we talked about ruling. Let's talk about volume of evolution or surface of evolution. Let's hide this. Let's take this curve, doesn't really matter. I have this curve, and this curve, you see, I pointed it, it highlighted. It gives me a pop that says this is C Bezier 223. You also see it at the bottom. Look at the very last bottom line at the center over here. Look here over here when I point now, when I'm pointing at the curve, you see that C Bezier 223 tell you the X, Y, Z position and what's the parameter value of that curve if you really want that information. This is this curve over here. So I know that. So I'm going to use this curve for the surface of evolution. So I go to surface of evolution, I choose that curve, here it is, and this is what I get. And so the reason I get this is because surfaces of revolution are always around the z-axis. Now this curve is planar. So if I rotate a planar curve around the z-axis, I get this really weird disk. And this, I deserve it essentially, because I did something which is not right. But let me transform this. So let me rotate this. And so you see that the shape is immediately forming. Let me move it outside. You see that when I move the cross-section, and in fact the cross-section can be arbitrary, I can even rotate it along this axis, the shape is immediately updated. This is very cute. Okay, so make sure that your cross-section is not in the XY plane, because otherwise you're going to get something that you might not want expect. Okay, so let me close this transform. That's a good opportunity to talk a little bit about something I didn't talk so far. There is another control for the window configuration, which is this one. This is default object configuration. This is window configuration. This is the pop-up that I see over here now on the hierarchy, but I can also get to it from W on the OpenGL screen. Okay, so if I stand here and I hit W, I get this screen. And let me say that if you go to help, you get, there is a help here for all the key binding over there. So if you want to find all the key binding, they're also listed over here. So W, let's find W. W on the OpenGL window, open graphics window, optional panel. This is exactly the panel we were here. I'm standing here, W. So you can get help from here with all the key binding. Okay, so what I get here is control over the screen. First of all, I can control the closer and farther away window. This is cropped because the far, what we call the far clipping plane, is only 10 units far. I'm going to make it much larger and it won't show up. So if you get the clipping, like similar what you see over there, go and change the clipping planes. You see, I will change it back to 10. And this is again a yellow numeric value, so I can change it with the mouse. So this is the far plane, and there is also the near plane that will crop it from the front. It's useful sometimes when you want to look at the cross-section. This is exactly the cross-section of the curve that we plot in the plane that are then rotated. So now you can see the cross-section. That's useful sometimes to get a good cross-section of the model. Another very useful thing that you can see over here is there is something called anti-aliasing. Look at the quality of the lines. Talking about lines earlier today, you see that I kind of highlight it now, but look at the quality of the line here when I'm going out. You see that it's jagged, it's actually steps. Look at the line here. You see that it's actually steps because this is a raster display, and this is exactly the algorithm I mentioned earlier. Look at exactly at the top. What's going on here on the silhouette. You see that the lines are jagged. But now I'm going to apply something called anti-aliasing, and you see everything is much smoother. So that's a very advanced way of plotting curves, and this gives you a much superior result. So you do want to apply the anti-aliasing. You can change your background color to any color you want. Say, let's make it white for a second. Or you can choose gradient. Gradient is kind of useful. It's kind of bright here to a dark there. So I'm going to leave it like this from now on, anti-alias and better near and far windows. Okay, so we back to surfaces. We talked about surface evolution. There are other Boolean 1 and Boolean sum. I'm not going to talk. I'm going to talk about from curves because that's useful. If you want to create something which is more complex, and let me again delete everything. So start from scratch. I can do circles. Let's move several circles, and I'm going to then make them at once. This is my first circle, apply. Second circle, apply. Third circle is going to be smaller, apply. Fourth circle, apply. And then maybe a fifth circle, apply. And then cancel. So I'm done. So now I want to transform this, and I can zoom in on this, obviously. So let me move this one to here and rotate it a bit. And note that it doesn't rotate around the expected direction because it rotates around something down there, but that doesn't matter much. Let me move this circle here. Again, I can do it from here. Right-click, menu transform. And again, I can move it to this direction. And I get a sequence of cross sections, and now I'm going to fit a surface through. So I go to from curves, and I'm going to select them in order. And I get a shape that goes through them all, either approximating or interpolating, and I can change the order of the other direction. You will see a different shape as a result of that. And so you can get very complex shape by giving set of cross sections and creating the geometry. Okay. Another thing is the sweep. I'm going to skip the other two, but the sweep is also useful. Here, I'm not going to do it. You give a cross section, which can be a circle. You know what? Let's do it. It's also a very useful one. I'm going to use the first circle. You see the circle at the bottom. I'm going to sketch a curve of some shape, say almost a face. You know what, this is too complex. Let me do something simpler. Let me do something that makes more sense here. Okay. And let's do sweep. The section is going to be the circle. The trajectory is going to be this sketch. And what does it do? What does it do? It sweeps the circle around the shape. Now, this is very big, so let's make the scale much smaller. Oops, it's becoming very, very large. It's my mistake that I allowed it to do this way. Cancel that. Sweep. Again, we want the geometry to be this. We want this one to be 0.2, say. and we want to select the sketch. So we get this circle. For some reason, the section curve is not working right because it should have changed the scale, but you can always change the scale in a different way. And I will show you how. You can also give a curve which is a scaling curve, so the scale will change along the profile. I'll write it down. We do a good test here for this everything, no? Okay, but the other way is to simply scale the input. So if this is the input, I'm going to scale this one. And you see that the shape is scaling as well. So you can create sweeps this way as well, which is also a very useful tool. And you can do, again, Boolean operation with that. So all these are basic operation. There are many other things in this system, like the volumetric stuff that I'm not going to talk about. This is the heterogeneity. All the panels that I mentioned, some of them, like there is animation here that I'm not going to discuss. The control of configuration. When this is maybe still useful to show, when I'm standing on geometry, it's highlighted in cyan. And if I select it for some, say I want to do some selection operation, then for example, I can select several objects and delete them, or move them, or transform them, or change the rendering options of all of them simultaneously, like select 1, 2, 3, 4, 5, right click, and then render option, change the property of their display of all 5 of them. So essentially all those are selected, are not shown, so you don't see them, but I can select also this. So now I selected surface and all these curves and do rendering option and change all of them together. So selection is useful. But I mean, the selection color and the highlight color is set from this configuration panel. You see this range here. So I can change the highlight color if you rather have a green highlight color and the selection, the color to be yellow. I can change that, and now it's going to be highlighted in green. And if I select it, no, this is not what I wanted. Let's select it. Oops. If I select this, it shows in this weird yellow. So you basically can control the colors and lots of configurations from this window. Maybe some other useful stuff here is, let's see, what else do we have here? Okay, I don't remember. In fact, you can disable highlighting also here. So this is selected now, so I cannot highlight it. You see now everything I point at is highlighted in green because this is green, but I can do auto highlight, and now it doesn't happen. If this disturbs you, you can always disable it from here. So many of the system configuration are shown here, and you can explore that as well. Okay, let's see what else I can show you here. System special stuff, fun stuff. Maybe I will show you a little bit about what else we have here in the few minutes that we have left. There is a project called Sand Art that we can come and drop geometry, and like sand art, tipot bachol, that you throw on the sand, and you can create geometry. And I'm going to change the resolution to make something which makes more sense. And then let's start, and let's okay, something went wrong here, but it should work. Let me re-enter. We're not giving up. Let me change the resolution to something. So it actually continuously failing. Okay, so there is a problem here. So don't do sand art for now. Let's see what else fun we can show you. Let's do Geometry. Geometry, I didn't talk much about geometry. Geometry has some fun stuff over here. I can upload 2 images, and I have to go to where my images are. And I want images like this. Okay, so we're going to load Ben Gurion. And we are going to try to load Herzl. And you see a bunch of points, many points, kind of weird. We have to change the point size. So let's go back to here, make the point very, very small. Let's get back to there. And let's change something so it will actually take effect. Okay, make it even smaller. Okay, so now we see a bunch of points. And you see, I hope you see Ben Gurion here. I didn't plan on showing it perfectly. You know, I can do a perfect view. So that will be, let me do it optimally. So let's hide everything. And let's see the first view. You can see Herzl on the side now. I hope you recognize that. You recognize Herzl on the side? Maybe I should make the...
Yes.
Okay, let me make the points a little bit larger because I made them too small. Okay, so you can see Herzl on the side. I hope most of you will see that. And if I go, you know what, I can do it brighter. Gets to the screen. Oh, doesn't help. Okay, so let's leave it like this. But let's do him. Let's do Herzl brighter. Okay, you see Herzl now, I hope. And okay, now when I highlight it, definitely you see Herzl. If you don't see Herzl now, check yourself. Look on the side. Okay? But if I rotate it, you will see Ben Gurion now. You see Ben Gurion? In fact, I'm going to go to the perfect view. You see Ben Gurion now. So this is Ben Gurion, and somewhere here you can see Herzl. And so this is kind of fun because we can do a bunch of points that detail into shapes in different directions. This is one kind of fun application that we have here. We can do the same thing with blobs. So let me again load images. Ben Gurion. And just to show that it doesn't work just for these 2 images, let's take Rabin also. Let's do much higher resolution, say 100.
גרשון, אפשר שאלה?
כן. Go ahead.
אם אני בוחר להדפיס כזה דבר שהוא אוסף נקודות, איך המדפסת תלת מימד יצליח לעשות את זה?
Okay, it's not, I didn't say it's related to 3D printer. The question is, how can you print that thing? The answer is that, in fact, this we did on, let me show you, on a glass cube. There is you can see these glass cubes in many places. And so you can see, in fact, in this case, you can see Einstein. And in here, you can see the E equal mc squared, the conversion of matter and energy. I will show you bigger when we are done with the presentation. So here, these are blobs, and you see again Ben Gurion here, and you can see Rabin here. And again, I'm going to go to the perfect views, so it's going to be easier to see. Okay, I lost something. Let's again check if they are not bad in here. We have been here before. There is another option I didn't mention. So if I do OK here, you can always go to here, transform, recenter the object. So in fact, you get the object and you can recenter through it. So if you lost it, you can always find it. So this is Rabin on the right, like this. And I'm trying to rotate it so you will see Rabin in the front. Kind of hard to match it, but here is Rabin. And here is Ben Gurion again. Okay, so this is fun stuff you can find here. We can do auto letters, it's also fun. All the fun stuff is in here, I didn't show you at the beginning. So you see love here, and Amor from there. In fact, this is intersection of two geometries that create these shapes. So I can do solid, it's going to be more convincing. So these are really objects you can 3D print. Eduardo talked about 3D printing. From here you see this, from here you see that, and we can do any text we want. So I can say, here I can say this, and here I can say that, and let's see, here is this, here is that. Okay, this is cropped because S, the S of this is not high enough, but this is this, and this is that. So this is another fun stuff. I don't know what else I can show you here. Talking about algebraic computation, we have a very strong solver that solves algebraic constraints. And so this is one example for this. We have a triangle and we want to find the 3 different circles that are inside. This is called the Malfatti problem. Middle Ages, Malfatti was some Arabic scholar, and he was supposed to extract the biggest marble cylinders that can extract from this pyramid or prism, if you like, that he had. Think about 3 dimension. And so it can be formed as, if I recall correctly, 9 algebraic constraints. And if I change the shape of the triangle, the prism, if you like, in 3D, it finds out the 3 biggest circles that you can fit inside. In fact, it's not always the case, but it works in most cases. I mean, I'm not going to go into details. Another thing that I can show you from here is there is something called the Malfatti problem. It's a special robot that has a base that is fixed, and this is the platform that moves. And the 6 degrees of freedom that typically robots have to X, Y, Z translation and X, Y, Z rotation are translated into the length of these 6 bars. So if I'm going to change the length of these bars, you see that the entire platform is moving. Sometimes jumps because it's singular. The thicker bar is the bar that is actually changing. Okay, so Stewart platform, and we can simulate it again by solving the algebraic constraints. The last thing I'm going to try and show you is the kinematic stuff. Let's see if it works. You know what? I'm not going to show it from here. It's too complex. I'm going to load some examples. One of the things that we have here is load geometry. If I load geometry, it opens up a pop-up that I can go and load existing geometry. In fact, I'm going to load geometry that exists in your installation. So if you install Irit, Guirit, you're going to get, something similar to what I'm going to show you now. In the directory when Guirit is installed, there's going to be a directory called models, which is exactly identical to this model. And let me try to load some kinematic example, and I'm going to load one of the simple ones. Let's see if it works, because I haven't tried it for a while. If I want to edit something that exists, I didn't show you, but I can always right-click on the box, and there is edit geometry. Edit geometry takes me back to the same panel I created the geometry, so I can change the geometry. So I edit the kinematic, and hopefully, if everything works out fine, I can do a solve, and I can animate that. So let's do global solution, and let's animate. So you see now, this is a piston in an engine, Buchna shel Manoa, that is moving around. In fact, it gives you all 4 options. In fact, this is the second option, this is the third solution, and this is the 4th solution. Second solution, third solution, fourth solution of the motion, and then the first solution again. So this is kind of stuff if you want to play with kinematics. This is again the algebraic solver. So